Hello everyone, I hope you all are doing great. We heartily welcome you all to our YouTube channel cadcaemaster. If you enjoy what you see, hit the subscribe button and turn on the notifications so you never miss an upload. Well, agenda for the today's session is to deal with the ANSA connections, and then we'll also see about the patch mesh, the feature manager, about the holes and features and other options too. The connection manager, how we gonna use it, and different types of connections like the 1D, 2D, and 3D, likewise the spot-welds, adhesives, and seam lines. And finally, we'll also look at RBE2s, how we gonna use them. Yeah. Well, let's get started with this session. Well, let's open the model. So I'll be working on the same BIW which I had used before. It's just for educational purpose, guys. Yeah, this is the one. We'll focus on the contacts. So this is complete BIW. It has assemblies, sub-assemblies, yeah, subsystems and all, right? So let's say we can consider this one. This is kind of a sub-assembly which has multiple components, right? So initially, if you open ANSA, it will be like this, in the sense in the entities mode, right? You can even switch to PID mode, and you'll be having all the elements with respect to PIDs, whatever you are having it here, right? So this is not exactly the same. So with respect to the automotive components, you'll be having a set of PIDs. Even you'll be having the includes, very important. So right now, this is just an execution model. I don't have any includes. So I'll be creating one include. So I can just name it as front module. Yeah. So I can just save it as okay. So it has these all the files. Now in this module, this is the includes. Means everything is here. Out of include, what and all are there, everything is listed here. So it has the properties, material, geometry, as well as elements, right? Just remember. So I have created this front module. There's nothing inside it. I'll showcase how to move the components inside this. Okay, let's focus on this component and these two sub-assemblies. Okay, let me just activate I0. I'll be isolating this plus this. Okay, if you again middle click, it will only show these two. So for my convenient, what I'll do is I'll just lock this view. So we can just go to store lock. Okay, the name I would like to mention it as not full BIW. This time I'll just name it as front module. Okay, so you just need to remember, you need to do these all the things while you're working on your models. Yeah, very important. So we have the full BIW and the front model, both are available. Okay, now let's say if you have everything, again you don't need to isolate like that. If you just right click on the front module and just show only this, you'll be having only the front module available. Okay, well, now I would like to mesh this. So before meshing this one, I would like to measure the distance, because this is a kind of half circle, semicircle, so it might be considered as a fillet. So it's totally on an average 8, so in the sense 4 mm mesh. If I consider, so it will be only 2 divisions, so I would like to have 4 splits. So if you want to maintain this geometry, it will be quite difficult with 4 mm mesh. So in industries, 4 or 5 is standard, depending upon the requirement again. So right now, with my interest, I would like to go with the 4 mm mesh on this. Let me directly take you through the direct mesh. So I'm not going to do anything. I'll simply select whole model. I'll specify the target length as 4. Nothing here, no changes, everything is same. So now if I click on middle click, let's see what exactly it does. Okay, as I said, it will try to mesh the model, but it is not that accurate. So these are the fillets which is not properly captured. You could see there is a curve, right? And here we have the washers and some holes also there. There is no the washer has been created. You could see like here also, right? So here you could see it is not that good. So now how do we get it in a better manner? So for that I'll simply press Ctrl Z once again. Yeah. So what I'll do is I'll try to recognize the features and try to store them so that while I'm working, uh, these features should be captured properly, and whatever the treatments I'm going to apply, it should be stored. So for that, what you can go do is you can go to the Feature Manager. Okay. So here you can go to Edit Features. So what and all you would like to. So I would like to capture the hole. Okay, strict, and I would like to capture the fillets. Yeah. So let me just do one thing, recognize. If you click on that, it will show everything. So look, I would like to capture the holes. Okay, I would like to capture the fillets. I would like to capture the chamfer. If you have the ribs, you can capture it, but as of now I don't have the ribs, so it doesn't capture anything. The maximum radius is this much, and so here this is the angle and this is the radius. You could see the holes. Wherever we have the holes, it will try to capture. Okay, this is first one, and if you simply click on recognize, ANSA will capture these two. You could see holes and fillets. Chamfers we have activated, but there is no chamfers. Now for the fillets, so these are the regions, right? So what I'll do is you can see the minimum radius. I've just filtered it, and everything is 4.5. Only these are the regions with the fillets. You can select everything, Control All, right click, and you can use this mesh treatment and new. And here you can select this option to defeature. If you don't want, you can just sharpen it, and you can see these are the details. So one is 3 rows, one is split, one is sharpen. So depending upon the requirement, you can select it. But right now I would like to use the rows auto. If you want, you can specify the rows. Okay, and length also you can specify, but right now I won't. Well, so here rows specific 4 rows, let us put and see what it does. Okay, so you could see this particular treatment has been applied. So now for the holes, if I select everything, it shows everything. These are the oval shapes, it shows oval, round. Yeah, and if you want to filter it as with respect to diameters, you could see the first one is the 6 and 7, alternately 10, 13 and 37. Now for this I would like to create again the mesh treatment. What and all it has fill options. If you don't want, you can fill it. Let's say there's a 6 mm and 8 mm holes are there. Now if you don't want, you can just select only these two and you can just select defeature fill. So wherever it finds the 7 mm and 8 mm holes, it will automatically fill them. Okay, now here I would like to activate the zones. So here it shows, if you just click on here or if you just hover on it, it shows the zone width, right, and it shows the zone diameters. So right now I would like to specify the zone width as 4 mm mesh. In the sense, let's take it as 3 mm width is fine. So rows, if you again click on this, one more row if you want, you can add it, but right now I would like to have only one row. You could see zone 1 and zone 2, so I would like to have only one zone. That is fine for me, and I'll simply click on number of nodes. Yeah, so this is important. If you just hover on it, it shows number of nodes each. If I select auto, it will automatically try to retain for the model. I'll simply click OK. Yeah. So now these two are the things which I would like to maintain. So it's already done here. Now you can go to the batch mesh. So we're in the generate mesh only. We have this advanced option in 25. Now again select the same everything. Mesh, I would like to keep it as 4. Let's see with the 2 mm. Okay, let's see now. What it does is, you could able to see now. Yep. Now here it try to retains the feature, but the number of zones we have applied for, but it don't take because of this mesh size. And here you could see it has automatically applied the zone cut, so which is very essential for us for defining the contacts. Okay, and mesh and all not that good, but right now it is good with respect to mm, but my the industry requirement is 4 or 5. So let's try with the uh, target length 4, but here I can't do like this. What I'll do is I'll simply improve this one with reconstruct with 4 mm. So right now it is 2, so I'll just select everything. Now I'll zoom in here, middle click, and again one more time. So you can again control Z and you can do it, but I just wanted to show how this reconstruct tool work. So if you already have the mesh of any size, you can use the reconstruct. You can set the mesh target length and you can have it. Right now here we could see it has created the proper zones with respect to the target length 4. Middle click, and now you can see these are perfectly fine, straight, no issues with the fillet. Features has been properly captured. You could see we have the zone cut. Click OK. Now what about the quality check? Very important, right? So let me activate this from here. Criteria, aspect ratio, skewness, but I haven't defined it yet, right? So for that you can go to the mesh settings. Here only these many are there. Yeah, it has been defined. Aspect ratio 3, according to that it has created this. Only off element is somewhere 1, so if you want to show that, show worst, you can click on this. It shows this is the one. So how do we avoid this? So the best option is you can simply improve. You can go this, fix quality, just select this, middle click, then fix, or else you can try manually moving this one. If it doesn't fix, what you can do is you can activate the brush. Brush is activated, press tab to switch to fix quality. Try to move it like this. Yeah, but the zone cut is affected with this, so I would like to slightly move it so that it's fine for me. Yeah, okay, now there is no issues with the mesh quality, everything is fine, but still I feel the mesh distribution is not that good. So okay, now you can see the quality, oh, a lot, right? So what I'll do is I'll just go to module, show only. Now this is fine. Okay, so now mesh looks fine, but still let's see how it will work with respect to improve. I'll just select the smooth. Okay, now just concentrate on this area. I'll select everything, zoom in, and here just look at this region here and this region, what it does. Show old, there's no difference at all. Okay, But if you directly mesh and use the smooth, then you will see the difference. But I always recommend you people to use smooth ones if you mesh your model. Yeah, that will help us a lot. Okay, now let's focus on the main intention of this particular session, to create the connections. Now, in between these two components, assembly or subassembly, I would like to create the spot welds. So for that, what you can do is, in 24 you will be having a tab here for the connections, but here in the connection manager, we have the create, define manual, everything. Okay, and in the utilities we have the convert and more. Okay, just remember this. So if you want, you can even activate this, you can bring that tools here and you can start working on. But right now, as I don't have any of the connections recorded here, so I need to create it manually. But in some cases you'll be having the connections that you need to import it to the another model in automotive industries. Okay, from the old version to another version, let's say there'll be design changes, so you don't need to create the contacts again. So you just need to export them as the formats available here. So let me just show you the output connections. We have the JT format, XML format, okay, VIP format, VIP2. So very important thing is this VIP, it only exports the spot welds. VIP2 and XML and MCF 3.11 and JT, these all will export all the formats like the curves, spot welds, the points and the surfaces. Okay, adhesives, everything. Remember that this is the only difference. If you want to input them, so you can again go to the input and you can just select the location of the XML file and then you can bring it back here. That you can try manually, but right now I'll show you how to create it manually. So I would like to define a point relative, so somewhere here one. Let's try. So this is the one, and two. You can define it. So I'm just creating roughly. So main intention of this session is to get to know how we can create the connections. Okay, yeah, so I'm doing it approximately. Yep, so these are the locations where I'm creating the reference points. Now I want to convert these points to the spot welds. So you need to create them as a representative first. You can just try to do it from here. From 3D points, you can select everything. So it will only select the 3D points, middle click. So it will ask you which type of connection type you want. I would like to define it as a spot weld. So we have the different types of connections, rivets, screws, connectors, clip. Okay, so right now I'm just going with the spot weld. Rob scan, it will also work like a spot weld, but different properties will be there. Yeah. So now you could see we have these spot weld representations. So now what I will do is, so you could see automatically if you just close it and reopen, it will recognize these representatives. Now it hasn't defined any spot welds. So how do we define it now? So it is only on this PID. It should be between these two PIDs. For that, I'll show how we can define them. So first thing is, it has recognized first property one PID. So important thing is you need to define the diameter for this model. So what I'll do is I'll just select all, right click here, modify. I'd like to take it as 10.8 as the dia for all the spot welds. I would like to define second PID, which is this one, right? Middle click, just click enter, so that it should be recognized for all, right? And now once you do that, so you can come here. Keep in mind you need to select everything again, select all. Here in the clips you have all the details, what and all you can define. In the dynamic you just define the which type of representation you want. So most of the Spot-welds will be having the RBE3-Hexa-RBE3, and depending upon the solver you're using, you need to define it again. So right now I would like to use the Hexa-RBE3. So here RBE3 pin flags, okay, and these are the degrees of freedom coupled, and only translation degrees of freedoms are coupled, yeah. And here all the degrees of freedoms are considered, and now separate reference C pin flags will be there for each. And here very important thing is the property, you need to define it if you want. So let me specify the property 001. This is the PID it should create for the P solid. So I'd like to duplicate hexa, means I would like to have 2. In automotives sometimes they require 1, or sometimes they would like to create 2, duplicate it. So here I would like to take it as, instead of diameter I would like to take the expression. So here as I defined 10.8, I would like to take it half of this, so 0.5 times of t would be my equation of the second one. Let's see what it does. Okay, here flange positioning, so if you remove this, it will try to move your flange position. If you just select this one, it won't move. Depending upon the requirement, you need to activate or deactivate this. Let us see now. So let's see here, I'll simply apply this one, realize, and you could see it has been created, right? Now I'll simply click on close. Let's say whether it has replicated or not. So for that I'll simply hide one of this, and we have 2 Spot-welds. Yeah, from here to here it is approximately 10, and this is half of it. Yeah, so like this you can create the Spot-welds. So yeah, again this one show only. I would like to see the solids 2 show. Yeah, so if you want to see the RBE2 and RBE3s also, you can see here. So you can again activate the first level. You can even try all, it won't. Yeah, so now these 2 PIDs are connected with the Spot-welds. Now how do we create the adhesives and seam lines? So it is again the same, so I'll just simply show you what to do for that. So I'd like to create a curve, so you can just go with the curve. 𝐂𝐀𝐄 should be here somewhere. Never mind. 3D points, circle, points, edges, nope. Okay, let me just go to geometry and 3D sketch. So I would like to, sorry, yeah, from here I would like to take the curve. Let me just draw a curve like this. Okay, you can middle click, so this curve will be created. You can just activate this. Now again you can go to Connection Manager. So this time I would like to again create from curve. You can just select the curve, middle click, what you would like to have: spot line, adhesive line, seam line, hemming, bolt. So these are the 2D connections, 1D connections, and 3D connections also will be having. So these are the 2D connections. Now I would like to have the adhesive line for this. So yeah, so I can just simply close now. So I can simply close this. Again, activate the connection manager. Yeah, here it is adhesive. Here it is spot. Now for this, again I would like to have the same format, RBE3-Hexa-RBE3 for this. And before that, I would like to again define one more property, PID is this one. Middle click, enter. Okay, it will ask you for the width. So I would like to take the width as 8. Enter. Height would be 0.3. These are all the rough dimensions I'm taking. It is not the industrial standards, but I'm just taking it here. Just remember that. Okay. Now for this, I'd like to go with the RBE3. So now step length it is asking. So what is step length? Is this one. So it shows the step length. So I would like to have the step length as 5. Okay. Step index length, width, expression if you want you can put it, but right now nothing needed here. So number of steps, so important. So how many steps you want. So if you just hover on this, you'll get to know. You can see there is number of steps 1 in the sense like this, number of steps 2 in the sense it will have 2 layers into this. So right now I would like to keep it 1, so that's fine for me. And here we have the keep all branches. I'll activate. I would like to even insert the RBE2s here. Yep. So to define the PID. So for this 1002, I'll mention. I would like to realize this. PID 100 is not a p-solid property. Okay, sorry. Whatever the property I have defined, it is not this. So what I'll do is I'll take the same 000 12 enter. Okay. Yeah. Now it's been realized. So while defining the property, it wasn't took properly. So now I had defined the proper PID for this. Now it is fine. Now let's see. So status is okay. Let's see how it is recognized. Click OK. And now here you could see it has been captured. So here this is how it is. But height is too less, right? So number of steps, number of layers I can maintain 2. Height also I can increase it for this. So I can activate the connection manager. Can switch to this. What you can do here is for this. So I can erase this. I'll define the number of layers as 2. Yeah. And then here height would be, I'd like to take it as 1 mm. Yeah. And yeah, step length is fine for me. Let's try with the 5. I now realize I could see this is how it looks like. Number of layers 2. Realize this is here, it is number of layers 2 like this. Number of strips, I'll mention it 2. Realize, and this is how it is. Yeah. So if you click OK, this is how it looks like, right? So like this, you can create the adhesive lines, spot welds, seam lines, rub scans, and etc. All the kinds of 1D, 2D and 3D contacts for your model. And one more important thing is how we define the like screws and also representation. So if you would like to join these two, you can utilize the RBE2. You can switch to here many nodes. So usually for this cases you can activate this one, closed loop, select these two and even these. This is important because for that only we create two layers so that the representation should be proper. Yeah, now this is fine. Middle click, you could see it will ask you for the convex new node. It's a convex hull centroid or the average position. You can just select it as per the requirement. I would like to take it as centroid hull. So finish. So this is how you can define the connections with respect to RBE2s as well. So sometimes, let's say for this, I'll do it again. Yeah, this is fine. Click. Yeah, so this is how it produces. Sometimes you might face RBE2 representation sometimes in the presentation parameters. So here by default this will be activated, optimized RBE2 draw. Okay, if you are having it, it only shows this much, means it won't show all the RBE2s, it will only show one row like this. Remember that. So if you want to have the proper visualization, you can switch to presentation parameters. So before it was here, I'll show that, and I can simply apply. You can see this RBE2 representation. So right now it is not here. If you right click here in the menu bar, so you would be getting this presentation parameters. Yeah, so now this is how you can just produce it. And let's say how do we convert this. Let's say what I'll do is I'll just try to convert this spot weld to representation. So let's say for that you can switch to Connection Manager, convert connection type, connection to geometry, nope. Okay, from FE to connection point, I'll just select this. I'd like to select the PID. This is the one. I'll simply middle click. Yeah, so if you do like this, it will create the again the representation for your spot weld like this. It should be at the center. Okay, now let's see how do we export them. So you can just go to File, Output, Connections, XML format, Connections, Visible All, Connectivity type I would like to take with the module ID itself. Click OK. Define the location. Just click OK. Yeah. So now let's see how do we just add these to another model. So let me just open one more ANSA. So yeah. So now let's do the same. You can go to File, Input Connections, XML. This is the one. So click OK, and now you could see we have all the connections here added and the seam lines, right? So now this you can take into account and you can realize in this model. So this is how it works in the automotive industries. Anyway, it will be created. So let's say right now what I'll do is I would like to move these. So let me just delete this, not needed for me. Send to new include, right click, new, from visible you can just select, yeah, middle click. So here you can just define it as front module reference. Okay, and now here you could see I would like to delete this. And now, so in the this include we have the connections included here, right? And we have the adhesive line. We have the only elements in this. Out of include we have everything. Let's say if I just show only this much, we'll be seeing only the elements which are here. Okay, outside this, not everything. If I just select this one and show only, it will only show these and all are included into this include. And in the automotive industries, this will be the format. And if you would like to output the same, you can just take this as an output as a single file, as a separate file, and you can start working on it. And if you want to replace this, you can just delete that include, and you can bring the whatever the edit new version we have it, and just replace that. So likewise, the team will play with the different components and the sub assemblies. Let's say some people are working with the front module, and some people are working with the rear, and some people are working with the panels, the A plus B plus. So they only take that include which belongs to this, and they only work on that, and they have these all the nomenclatures, everything included into that. Let's say we have this one, the minimum ID is this much, so these are the range where they store. Let's say we have the properties here, P shell for this module, the front module, there will be a specified the maximum ID and the min IDs. Within that only these all should lie. So depending upon that, for each and every subsystems we'll be having the different includes, and we work on that include only. Let's say right now I'm going to play with the contacts and everything. So if you just do regularly whatever you do without dealing with includes, so all the connections will be stored somewhere outside the includes. So that is very difficult to again bring it back to the current include. So what you can do is you can just right click and you can set as the current include. So whatever the changes you're going to do, it will be stored in this current include. So that is very important. So wherever you're working, let's say if you're working with the front module or the rear, the front dome and the LDs, wherever you are working, so try to activate that LD or the domes and set it as current and start working on it, so that whatever the changes you do, it will be stored in that particular include itself. Okay, yep, that's all about the session. Finally, to summarize, we had gone through ANSA Connections, the patch mesh, the feature manager, the different types of connections like the Spot-welds, adhesives, and the seam lines. Yeah, the next session will cover the advanced topics on solid meshing. That's all. Thank you.
We heartily thank you all for watching this video. If you enjoyed this video, don't forget to hit the subscribe button and give it a thumbs up. Follow us on Facebook, LinkedIn, and Instagram for behind the scenes content and the updates. Stay curious, stay awesome, and see you again in the next video.